This is a continuation of the lesson on solving absolute value equations and inequalities. We're going to go back to solving equations first. So we started, or finished I should say, last week where we solved absolute value of x equals 3, and we saw that it would be positive 3 and negative 3, and the graph looks something like this. We also saw that if we tried to solve an absolute value, like absolute value of x equals negative 3, it wouldn't make any sense because if you try to plug in a number, you're never going to get a true statement, and we said that that would be no solution. We did easy versions of these. We did not do the difficult ones. So here were the steps that we copied down last Friday, and now we're going to work through some of the more difficult ones. And this first step right here, step 1, is going to be really important now. We hadn't been using this previously, and this is really the focus of these two final lessons in chapter 3. So the first thing I need to do is get the bars alone before I do anything else, which means on both sides of the equation, I'm going to multiply by the reciprocal of 3, because this is 3 times the absolute value of n. If I fail to do this at the start, I'm going to get 2 answers. They're probably going to look like they're right, and they will be horribly wrong. This is going to cancel. I'm going to be left with the absolute value of n equals 5. Now I'm going to split. So step number 2, write 2 equations, one that's positive, one that's negative. Remember, these are equations right now, so I don't need to worry about and or. So I end up getting n equals 5 and n equals negative 5. You could also write it as n equals 5 or negative 5. You could also write it as n equals 5 comma negative 5 or negative 5 comma 5. Or you could also use set builder notation like this. I'll show checking in a minute, but that just involves plugging the value back in. We've got 3 more in this section to look at. Number 4. So it's 3 times the quantity, which is the absolute value of w minus 1, minus 2 equals 4. So the first thing I need to do is move this negative 2 to the other side. So this is actually plus negative 2 plus 2 equals 4 plus 2. 3 times the absolute value of w minus 1 equals 6. Now I'm going to move the 3 to the other side. I don't want to distribute the 3 inside. I also don't want to split right now and set them equal to positive and negative 6. That'll mess everything up. I'm going to multiply both sides by 1/3. Now is the time where I'm going to split. The only way I can drop absolute value bars like this is if I make one equation equal to positive 2 and one equal to negative 2. Then I'm going to solve. If you prefer to do it horizontally, you can. I'm going to do this one vertically. I'm going to add 1 to each side and get w equals 3. I'm going to add 1 to both sides, and I'm going to get w equals negative 1. So here are my 2 equations. Remember that you're looking for 2 equations in most cases. We can do a quick check on this. So the original problem was 3 times the quantity, which was the absolute value of w minus 1, minus 2 equals 4. So my checks would be 3 times 3 minus 1 minus 2 equals 4. 3 times, it's a 2. This is just a normal 2 again. And this is 6 minus 2, which is 4. And then I would also check it for the other one if I was doing a thorough check. Usually one's slightly harder to check than the other one. This looks like the harder one. This is going to be negative 2. This comes out to be positive 2. And it does check out. Let's go over to the last 2 problems. On number 5, this is negative 3 times the absolute value bars. So I'm going to multiply both sides by negative 1/3. This is an important part of the problem. I want to make sure that this is positive before I split. Because like in this problem, way up at the top, right here, the other side was negative, and we found out it was no solution. So initially this looks scary that this was negative, but it goes away, and now I split, and I will get two solutions, and they will check out. If you do these carefully, a check is optional. The last one has a catch. Okay, I talked about how it's important that this negative turned out to be a positive before I split. If that does not happen, then I can't solve it. So in this case, on number 6, I multiply both sides by a -2 to isolate the absolute value bars. Multiply both sides by a -1/2. I get absolute value of 3p equals -6. And this is no solution. I have to remember that this is the distance from 0, and it can't be negative. Not only will I waste a few seconds if I try and solve it, and it will probably look like I have answers that work, but if I plug them carefully back into the original equation, they're not going to check out. I would suggest not even wasting the time, and if you notice that right before you're splitting to your two equations that you have a negative, when it's in the equation like it is here, that you just stop and you say no solution. The other part of the lesson is finishing solving absolute value inequalities. So we did number 12, and actually you finished 13, so we're going to look at the last few. On the last few, we're going to repeat some of the same things that we were just doing. The only difference is we're going to notice that these are not equations, so we're going to be doing and or. Before I decide if it's and or, and before I do my splitting, I'm going to first isolate the bars. Now I'm going to split, and I'm also going to make a decision as to whether this is and or. This is read as less than. This is going to be an and, which means I'll have to sandwich it back together when I'm done. And the second equation will be 4 minus x, the same. Flip the inequality and flip the sign. I'm going to add -4 to both sides. And I'll get -x is less than or equal to -2. And I'll divide by a -1 or multiply both sides by a -1. So the first thing I see is that x is greater than 2. So I'm doing yet another flip. And I also did this weird flip here. Let's try the other one. I think something like that will happen in the other one. I'm going to add -4 to both sides. -x is greater than or equal to -6. Get rid of this -1, either divide by -1 or multiply. X is less than or equal to +6. And then I'm going to sandwich it together and put x in between the big number and the small number. And all that flipping worked out. And then here's my graph. I'm not going to go too fancy with my graph. We spent time already graphing these in another lesson. So this will be a dumbbell. Number 15, I'm actually going to rewrite this and do c minus 2 is greater than 6. It looks just complicated the other way. This looks ready to split, actually. It looks like I do not need to get the bars alone. So I'm going to do c minus 2 is greater than +6. This is great or. and c minus 2 is less than negative 6. I'll add 2 to both sides. So c is greater than 8, or add 2 to both sides. C is less than negative 4. When I graph this, this should look like oars on a boat. They should go in opposite directions. Here's 8. Here's negative 4. Open circles. All right, let's do a couple more. Number 16. This looks ready to split as well because the bars are all alone. So this is 2y minus 3 is greater than 8. This is great or, so this will be or, and 2y minus 3 is less than negative 8. Divide by 2. I'm not dividing by a negative, so I do not need to flip the inequality sign. So here's my answer. Again, these are not going to be super technical graphs. I'm just going to do kind of some fast graphs here because I think we're focusing more on the solving process right now. That's the new stuff. All right, number 17, absolute value of 4m minus 3 is less than negative 6. I'm going to split. I don't know if you're noticing, there's something kind of weird about this. Usually when I split, this is already positive. So I'm going to try this closely. It doesn't mean that this is necessarily wrong, but something weird's happening here. It's saying to me that this needs to be less than negative 6, which means that this whole thing here has to be like negative 7, which seems weird because absolute value bars aren't going to produce like a negative 7. If I had a negative 7 in the bars, it would come out as a positive 7, which means that this is not true. So let's try this and see what happens. So this is less than, so this is an and. I'm going to do it vertically this time. And this isn't making any sense. This is m is greater than 2 1/4, and simultaneously m is supposed to be less than negative 0.75. I can't pick a number and have it be bigger than 2 1/4, because if I did that, let's say this is 2 1/4, that would be over here, like 3, but then it wouldn't also be less than negative 3/4, and negative 3/4 is maybe down here. If you actually caught this in the beginning, you wouldn't have to do any of this work, so I just wasted a bunch of time. No matter what number I plug in, this is not going to work. This is no solution. And right here I sort of showed why that was going to happen. And again, I could have stopped at the beginning and done almost no work for this. Last two, number 18, I'm going to add 2 to both sides. I'm going to divide by 2. Now this one has that weird thing again where it's negative, but I don't think this one's going to be no solution because this needs to be bigger than negative 1, which means it could be positive. So let's split. and this was great or. And let's graph this and see if this works. I messed up my graph here. So here's 2, 3, 4. This is or, so it needs to be less than or equal to 4, or x is greater than or equal to 2. So less than or equal to 4. Greater than or equal to 2 gives me a graph where everything is shaded. So that means that this is all real numbers. Essentially, anything will work or check out for this particular problem. And the last one, if I lost you on number 18, this one I think is very similar. This one's already isolated, so I can split it. Again, I can have an absolute value be bigger than -3. So for example, this whole chunk could come out to be a 5, which is bigger than -3. So I think this is going to work out. This is great or 5 minus 2y is less than +3. And then it has another flip through the process of solving it. This is or and another flip. Before I box this might be kind of weird like the previous one. We said that or usually go in opposite directions, but this one says y is less than 4, y is greater than 1, so this open circle is actually filled in by the other graph, and then this open circle is filled in because the other graph goes this way, and the whole number line is filled in like on number 18. So this is also all real numbers. That's the best answer, meaning anything will check out that I plug into this particular problem. So if I don't believe it, I could test a number, like we could test or pick -1, and the problem was 5 minus 2 times y. Absolute value of that whole quantity is greater than -3. 5 plus 2 greater than -3. Absolute value of 7 is greater than -3. So no matter what this junk becomes, it's going to have to come out positive, which is going to make it bigger than -3 because of the absolute value bars. So that was the lesson wrapping up chapter 3, solving absolute value equations, which were a little bit easier and had 2 solutions, and absolute value inequalities, which involve and or.